Soil washing has been used since the 1980s to treat contaminated soil. It uses physical separation and adsorption to remove contaminants from soil and into the aqueous phase. The process water used to remove the contaminants from soil is then treated and recycled throughout the soil washing process. Soil washing relies on a volume reduction approach. It treats the coarse-grained soil and separates the fine-grained soil for secondary treatment. The coarse-grained soil can then be beneficially reused on site, while the fines and organics can be managed through stabilization, landfilling, or thermal treatment, depending on your goals and objectives. Soil washing is a versatile technology and can be optimized to address a range of soil types and contaminant concentrations. The objectives of this project were to demonstrate soil washing as a cost-effective volume reduction strategy for PFAS soil treatment, to achieve Alaskan soil standards for PFOS and PFOA in treated coarse-grained soil, and to achieve reductions in soil leachate concentrations to meet US EPA risk-based screening levels for groundwater, to demonstrate that soil washing is a sustainable alternative to other treatment methods such as landfilling or incineration, and to show that soil washing can minimize waste and maximize beneficial reuse of on-site soil. The project was conducted on PFAS contaminated soil at Eielson Air Force Base in Alaska. PFAS soil concentrations range from the part per billion levels in AFFF source soil to concentrations in the hundreds of parts per billion range from construction soils. The design of the soil washing system was based on several rounds of bench-scale treatability testing on soil from Eielson Air Force Base. The system was designed to be mobile so that it could be transported to remote sites, and in the summer of 2021, the system was mobilized to Eielson and the demonstration was conducted. The soil washing system designed for this project uses a physical and chemical treatment train with 5 key elements: size separation, nutrition scrubbing, chemical treatment, dewatering, and wastewater treatment. The Eielson process was designed to be mobile and treat up to 12 tons of soil per hour. This size system is ideal for treating smaller volumes of up to 10,000 cubic yards of soil. The capacity for a full-scale system can be designed to meet volume and schedule requirements, and they can typically treat 50 tons of soil per hour or more. The first step in the treatment process is for excavated soil to be loaded into the hopper. Clean water is then added to the process, and the soil is screened to remove oversized debris. The soil then moves through a trommel, and the first size separation step takes place. The gravel fraction is washed and separated from the bulk of the soil and deposited into a storage bay ready for reuse. The soil is then sent to nutrition scrubbers, where it's mixed with processed water and the PFAS is desorbed from the soil and transferred into the water. The soil slurry is then sent to a hydrocyclone to separate the sand from the fines and organics. The sand will then pass through a dewatering screen to remove any excess water, and it's then deposited into a storage bay ready for reuse. The fines and organics are then sent to a thickener and then a filter press for dewatering. Processed water will then enter the water treatment loop before being reused throughout the treatment system. We achieved our objectives by showing soil washing is cost competitive with landfilling and can be up to 50% cheaper compared to incineration. We achieved desired soil and leachate concentrations for construction soils. We demonstrated that soil washing has less energy consumption compared to other treatment technologies like thermal or incineration. And having on-site treatment system results in less trucks on the road for transporting soil. We were also able to minimize the volume of waste generated and maximize the volume of soil that could be beneficially reused.